Okay, so we're going to talk about nuclear equations, but before we do this, we need to get a good understanding of the different numbers that appear in the periodic table. So I'm just going to make up an element here called element J. Now, I'm going to say that this has a big number of 100 and a small number of 50. And generally speaking, in the periodic table, you have two numbers. The larger number is called the atomic mass, and the smaller number is called the atomic number. So they represent different things. The atomic mass represents the number of protons and neutrons in that atom, and the atomic number represents just the number of protons. Okay, so bearing this in mind, we have different types of nuclear decay. The first type we need to know about is alpha decay. In alpha decay, an atom loses 2 neutrons and also 2 protons from its nucleus. So let's imagine that atom J here undergoes alpha decay. What is going to end up happening is we've lost 2 protons. So therefore that bottom number, atomic number, which is the number of protons, is going to decrease by 2. So that is going to be 48. In total, we have lost 2 neutrons and 2 protons. So that top number, which stands for the atomic mass, which is the number of protons and neutrons, or the number of protons and neutrons, is 4, so that number is going to decrease by 4 to 96. Now sometimes that can end up creating a totally different atom, but we're just going to write J here. Then what we do is we write down, in addition to this, what we have lost. We lost a total of 2 protons and 2 neutrons, so that is 4, and we lost 2 protons, 2, and we call that an alpha particle, or sometimes it is called helium, as that is the atomic mass and atomic number of helium. So what we need to remember with alpha decay is that we minus 4 from our atomic mass and that we minus 2 from our atomic number. Why? We minus 4 from our atomic mass because atomic mass represents the number of protons and neutrons, and in total there are 4, 2 protons and 2 neutrons. Why do we minus 2 from the atomic number? Well, the atomic number represents the number of protons, of which 2 protons have been lost in alpha decay. So if you want to try a made up example, if you write this down, could you please tell me what should go there, what should go there, and what are we going to put here and here as our alpha particle? If you could try that on your piece of paper now. Okay, so hopefully you pause the video and give that a go. We are then going to change this to 200. This is going to then be 54. And we have our 4 and 2 as our alpha particle that has been emitted from the nucleus, or we could write that as helium. So then what can happen is we can undergo something called beta decay. And beta decay is where one neutron is transformed, changed into 1 proton. So let's imagine our atom J here, let's say 150. So what is going to happen? Well, if 1 neutron turns into 1 proton, that means we've got one extra proton here that we didn't have before. So this bottom number, which represents the number of protons, is going to increase by 1. However, the top number, which represents the number of protons and neutrons, is going to stay the same. Because although we've had one neutron turn into a proton, it still means our total number of protons and neutrons is the same. So that is 100. And then what we're going to do is write down the beta decay, which is 0, as we have actually not lost any mass. And also what ends up happening is an electron gets fired from the atom, and that's represented with a -1 E. So that is our beta decay, which can also sometimes be written as beta. So with beta decay, we have +1 at the bottom and 0 from the top. Okay, so what can sometimes happen is, let's say, for example, carbon-14, which is a radioactive isotope of carbon, can undergo beta decay, and it would change into a nitrogen atom. And what I want you to do is to pause the video and try and write down what should go in the various boxes. Okay, so hopefully you've done that. If it's beta decay, our top number does not change as our total number of neutrons and protons stays the same. Our bottom number is going to increase by 1 to 7, and we have 0 minus 1 E, or beta, as our beta radiation particle. Okay, and then if, say, for example, I have a situation where I'm just going to make this one up. Let's say I have J 90, 40, and that was to go under alpha decay. Could you please explain what you're going to have? Pause the video and have a go at explaining what you're going to have there. Okay, so hopefully you've done that, and we're going to lose 4 from the top, as top number is the atomic mass, which is protons and neutrons, so that's going to be 86. 2 from the bottom, as that's our number of protons, of which we lost 2, 38, and then we're going to write down 4, 2 with our helium, or our alpha particle at the bottom, like so. So in summary, what we can say then is we can say alpha particles, 2 neutrons and protons are lost, so therefore it's -4 and -2. -4 from the atomic mass, -2 from the atomic number. Beta decay, 1 neutron changes into a proton, so -0 from the top, +1 at the bottom, and we have our alpha particle here and our beta particle, which can be sometimes written as an electron or beta particle at the bottom, like so.